The exponent rules, part 1. What I'm going to talk about is just what is an exponent and how does it look. So there are some pieces to it. This first piece is called the base of your exponent. Then this is called either your index, your power, your exponent. You're going to hear 3 different ways to call that. So that's what exponential form looks like. You have a base raised to some power. Now, these properties, I would say you should pause and write them all down. The first property is called the multiplication property. For you to combine these 2 exponents together, you must have the same base. So this A and this A must be exactly the same. Then you have a power and another power. What you can do is you can add those powers together. Second property, division property. You have a base A with the same base A, and they're dividing. So what you do with this power and this power is you subtract them. The third property on this slide is called the power of powers rules. And there are a few of them here. Here is a base raised to a power raised to another power. What you do is you multiply these 2 together, power to a power. Second example, you have a couple exponentials here raised to a power. What you can do is you can think about this like the distributive property. You can raise this to the nth and that to the nth. Same thing goes with a subtraction. You can distribute that n through, so it's a to the n over b to the n. Make sure you have those properties down. Now we're going to teach a thing. You've probably seen this before. It's called PEMDAS. It's a way for you to remember your rules, and I just want to focus on the 3 on the last slide. So, if you have an exponent, what you do is you go down 1 and you multiply. If you have a multiplication, so like this example right here, what do? We add them. And then our last one here, if we have a dividing of exponents, then we subtract the powers. That's this one right there. Alright, so either you can remember the rules or remember the PEMDAS, these little arrows here. Alright, so simplify the following. We have d squared times d to the 5th. So if we look at, we are multiplying these 2 exponents together. So here's our multiplying. What do we do with those powers? We add them. We're taking this 2 and this 5, d, and then 2 plus 5 is 7. So we have d to the 7th. When we first learned exponents, we learned that we could break this up into d and d. We could break this up into d and d and d and d and d, and then we would count them all up. That's what we did in pre-algebra. We don't want you to do that anymore. We want you to use these rules, so you can still get d to the 7th. All right, next example. We have 5 to the 7th divided by 5 to the 4th. So notice the word divided. So here's our divided. What are we going to do? We are going to subtract them. 5 to the 7th minus 4 is 5 cubed. And then you can throw that in your calculator. You may have that memorized. 125. The old way, I'll just kind of show you off to the side. You would take that 5, this is not what we want you to do, and you'd write it out 7 times, divided by 5 4 times, and then you would cancel all the like ones, and you're left with 5 to the 3rd. We want you to do it this way over here. All right. Last set of examples on this slide. We are taking t to the 3n divided by t to the 6n. So Dividing, we subtract the powers. So t, the power is 3n, minus 6n. So we get t raised to the negative 3n. On the next video, we're going to talk about what that negative power represents and what we're going to do with it. All right, last one here. I'm just going to bring this down. We have a power to a power. So we are doing an exponent. So we're going to multiply them. So we're like distributing in from here to there. So how it's going to look is 9 to the 4th raised to the 3rd divided by n to the t raised to the 3rd. That's another way you can write it. Now we're going to multiply those powers together, because that's our rule. So 4 times 3 over t times 3. So again, n to the 12th over n to the 3t. Are we done? Can we go any further? We can. We could go ahead and now say these are dividing, so we can subtract those powers. So n raised to the 12 minus 3t, and that would be our final answer.